Alrighty, in this video we're doing worded problems with quadratics, and usually what this boils down to is you get yourself a formula from like a diagram or something, and then you'll use that formula to find the x-intercepts or like a maximum or minimum of a quadratic or something. So we're going to do this example here with a rectangle. It is 3 centimeters longer, its length is 3 centimeters longer than its width. So it's going to be a bit taller than it is wide, and usually the thing that you're trying to find we're going to call x. So I'm going to call the width there x, and we have to write a sentence here that says let x be the width of the rectangle in centimeters. We know the area is also 42 centimeters squared. So if it has its length 3 centimeters longer, then the length is going to be x plus 3, because that's 3 more than x. So for example, if that was like 10, that would be 13. All right, then area is going to be pretty much x times x plus 3. So this is area of rectangle. Therefore, well, we know the area is supposed to be 42 as well. Area equals 42 centimeters squared. So that's where that bit comes from. So then what we can do is we can sort of subtract from both sides. So take 42, take 42. So 0 equals x times x plus 3, take 42. So generally when you're doing this, I'd encourage you to set one side to 0 when you're solving a quadratic like that. So we're going to do just that. Okay, so now we need to expand that out. X squared plus 3x, take 42. And 0 has to equal all of that. So then we're going to use the quadratic formula here. So we're going to label this bit as A, B, and C, just like that. So x equals minus b plus or minus square root of b squared, take 4ac, over 2a. There's our quadratic formula, and then we're going to apply that and work through. So let's do that. So we're going to get minus 3 plus or minus square root of 3 squared, take 4 times 1 times minus 42, all over 2 times 1. So you're going to get minus 3 plus or minus square root of 9 plus, now 4 lots of 42 is going to be 168 over 2. And then we're actually going to have to grab our calculator and see what that is. So maybe 9 plus 168 is going to give us that. And if I try and square root that number, we're probably not going to have a lot of luck. So let's get our two answers. They're going to be minus 3 plus square root of 177 over 2. So that's going to give us one answer, 5.152. So x equals that, or it could equal another thing. So you're going to get minus 3 take square root of 177 over 2, and then you're going to get minus 8.152. So we just have x equals 5.152 centimeters because length must be positive. So you can't have negative 8.152 because, well, you need a positive length. All right, so we could check that. 5.152 was x value that we claimed to have. So that's going to be the width of this rectangle. And then the length is going to be x plus 3. So it's basically going to be 8.152 because it's 3 more. And then if I times them together, I should get about 42, which I do, which is really great. You can also, at the point where you have the quadratic, graph it and find x-intercepts. You will see those two x-intercepts there. The other one we're going to do today is sum of a number and its reciprocal being 2.5, find the number. So let's call, let x be the number. So that tells us that x plus its reciprocal is 2.5. Now, you might be wondering, what is a reciprocal? Well, it's basically 1 over that number that you started with. So we got this. Now, whenever you see a fraction like this, I want you to times by x everywhere. So this bit will become x squared. This bit will become 1, because you're getting rid of the x on the bottom. And this will become 2.5x, just like that. So then you can rearrange. So you're going to get x squared, take 2.5x, plus 1 equals 0. And then you can use quadratic formula if you want, or technology. So if you're going to use technology, you'd be graphing something like this. That was the original function there. But if we do, well, the x-intercept should still match. So we're going to get 0.5 and 2, just remember those. But if I do the original equation, x squared plus 1, take 2.5x, that's a normal quadratic, and I get 0.5 and 2. So those are our two x values. So x equals 0.5 or 2. Now, why do we get two answers here? Well, it turns out they're reciprocals of each other. So either the equation would work. So if x was 0.5, you would get 0.5 plus 1 over 0.5. Well, all that is 0.5 plus, and this thing ends up being 2, which is 2.5. So that's good. And then if x was 2, you're going to get 2 plus 1 over 2, which I think we can agree is 2.5 as well. So that also works. So that's an example of what you might be doing with these worded problems. So we've just found x-intercepts in both, but be aware sometimes you can have to find maximums or minimums, and they're usually in between your two x-intercepts.